Alright, so in this video here, I'm going to show you guys how to use Desmos.com to answer one of the questions regarding a graph. So in this example here, we were given a cost function for producing table saws, and as well as the price demand equation for a table saw as well. And then as part of this, the rest of the problem here, you have to find the price demand function P in form of X first. And then I think one of the part is asking for the revenue function as well. So by revenue, we take quantity times time, times price. And then quantity in this class is referred to the variable X times price. And price is going to be P. But P is already being expressed in terms of X, so we just substitute what P stands for or equal to. Okay, so that gives us 300x minus x squared over 40. So that is the revenue equation. All right. So from the revenue equation and the given cost equation, the next question in this problem is that asking for the break-even point. So I think it's a graph both R of X and C of X to find the break-even points. Now, when we define profit, which is P of X, so we take all of X minus C of X, right? So when the profit is greater than 0, when we subtract the difference, if it's greater than 0, then we have a positive profit, and then if it's less than 0, then we have a negative profit. So when this difference is equal to 0, this is when we have a break-even point. So this is when, where we have break-even point. In this case, it's going to be more than 1 point because one is quadratic, the other one is linear. So pretty much by doing algebraic approach, we would just take 300x minus x squared over 40, and then set that equal to C of X. In this case, it's going to be 84,000 plus 60x, because if you bring this over the other side, that's how you solve for x. So doing by hand, we were able to isolate this, or this as far as we can. So I'm going to bring the x squared on the other side, and then subtract 300 on the other side as well. That's to be 240x plus 84,000. And then we times the whole thing by 40. So times by 40. Right, so that will give us x squared minus 40 times 240 is 9600x. And then 84,000 times 40. That will give us 3,360,000. Okay. So from here in algebra class, to solve for x, this is a quadratic equation. We will use quadratic formula, or we can try and factor this, but I don't think it's something we want to spend time doing, right? And that was x equal to minus b plus or minus square root of b squared minus 4ac over 2a, right? So imagine doing this by hand by plugging all these constants a, b, c into this formula and getting x value, right? So we don't want to do this. Another thing in this class, most of the problem we're doing are application. And application, trying to mimic the real world as much as possible. So these problems or these functions are not nice functions. They're huge numbers if you try and graph this here. So instead of doing this here, we're going to try and solve. So we can say we will graph and find the intersection points. So intersection points, it will be the break-even points. Okay, so break-even point. Okay, so just a quick guess here. So if we have R of X is a parabola, and it's upside down parabola, and then we have C of X would be linear or a line. Okay, so when we graph this here, the x coordinates is only going to focus on the positive number because the demand is going to be positive only. Okay, so we only look at the first quadrant. So for all of x, we're going to have an open downward parabola, and that is 300x minus x squared 40. So I'm just going to guess, you know, something like this here for, you know, r of x. So I'm going to say, okay, r of x like this, okay. And c of x is going to be a line at 84,000, and with the slope of, you know, let's say this is 84,000. With a slope of 60, so that up 60 over 1. So let's say here is my line here. Okay, so the break-even points are these 2 points here, right here. Okay, so this is where the cost is the same thing as the revenue. So the company doesn't make any profit. Whereas if you have a point here, this is where the cost is here, and then the profit is up here. Excuse me, revenue is up here. So you can see that's the profit amount by that much right there. Okay. So graphing this by hand is gonna be a pain in the butt, so we're not gonna do that by hand. Okay. So instead, we're gonna use Desmo. Is a online graphing generator website that we can do. It's still gonna be not nice to do this. It's gonna take a minute to figure out where this point of intersection here. But theoretically, if we would do this by hand, we should be able to solve these 2 points here. But we're not gonna do that. We're gonna use a graphing utility. Okay, so I'm gonna go ahead and do that. Go to Desmos. I've already plot the 2 equations ahead of time. So we got the cost, which is 84,000 plus 60x, and we have the revenue, which is 300x minus x squared. Okay, so when you graph it, okay, 1 second, it's just really large numbers because it's 84,000. So okay, so when you graph it, you don't see anything at all. You see something like this here, so you have to zoom out. You have to zoom out, and then you're gonna have to zoom back into the first intersection point. So the first intersection point is around here somewhere, right there. So click on it, and then it should show you the first intersection point right there, 363,785, and then so 363. So we can say 36375 no 785 105827 105827.12. Okay, so the first intersection point is this here. That is here. Okay, that's the first break-even points, and the area that represent profit will be right above, right there. Okay, that's represent the profit. So that's profit. Okay, and then this is negative. This is negative profit here. So that's negative profit underneath the cost function, negative profit or loss of profit. Okay. So now we gotta zoom in and find the other point. Okay, so actually zoom out. So I'm gonna go up. It's gonna be it's gonna be way up here. There it is. So I'm gonna zoom in. There is that point. Click on it, and that is the second break-even point. 9236. 9236. 9236. 9236 point 215, comma 638172 point 876. All right, so that is the second break-even point. Okay, so that's how you use Desmo for a large graph like this. Here, you have to zoom in out until you can see the intersection point.